As I mentioned before, there are many types of non-lump sum taxes with very different properties, and therefore, especially with the limited tools that we have in this introductory course, it's very hard to provide a general characterization of their properties. So what we're going to do instead is study a concrete and very common tax, which is a tax per unit purchased by consumers. So let tau be the per unit sales tax on consumers. And this is in dollars. And remember, it's going to be revenue neutral. So this implies there's going to be a transfer tau equals minus sign because it's a transfer. Whatever is raised by the tax, this is the equilibrium price given the tax. This is the amount of quantity purchased. So I apologize, there's a typo here. This should be this. This is equilibrium quantity. This is the amount of the tax, which is the total revenue raised divided by the number of consumers. That is the lump sum transfer that everybody receives back to make the tax revenue neutral. Now let's investigate what is the effect of the tax on producers and consumers. For producers, the tax has no effect. It doesn't affect the profit maximization problem, so we know that the supply with the tax is equal to the aggregate supply without the tax. Now let's look at the consumers. For a typical consumer, the maximization problem becomes maximized over Q greater or equal than 0 of its benefits plus its wealth plus the transfer that it gets minus the quantity that it buys times the price that it has to pay plus the tax. Now this is critical. When the consumer is facing this problem, we're going to assume that the number of consumers is so large that its own actions cannot affect the total revenue and therefore the transfer that it gets. So it takes this as fixed, as a constant. And that means that we can drop these two things out of the maximization problem. The maximization problem reduces what is in blue. And what we have, and this is critical, is that from the point of view of the consumer, the problem that it faces when the tax is there is equivalent to the problem that it faced without the tax when the market price was P plus tau instead of just P. That implies that the demand with the tax at any price P, and this is the market price, is not the net price paid by the consumer, it's just the market price, is equal to what it wanted to buy, or the demand, before the tax when the prices were P plus tau. Now, given what you have just derived, the effects of the tax on the equilibria and on the deadweight loss are very easily described graphically. So this is going to be price in dollars per unit. This is going to be the total quantity. And that would be the demand, for example, the supply without the tax and the demand without the tax. We have that this is the equilibrium quantity without the tax and the equilibrium price without the tax. Now, what happens after the tax is introduced? Nothing happens to the supply, so this remains the supply with the tax. But what happens to the demand is that it shifts down. It shifts down parallel by an amount tau. Okay? And intuition is very simple for why it shifts down. The consumer now faces a price that is the market price plus tau, so it has to shift down so that it's willing to buy the same amount that it was before the tax at the same total price that it has to pay. Now this means that the quantity with the tax shifts to the left and the equilibrium price with the tax shifts down also. Now, what is the deadweight loss? Well, it's going to be this triangle. It's the triangle, given that we are below, between the aggregate supply and the aggregate demand before the tax, without the introduction of the tax. This is the deadweight loss. Now, if you're curious why is that triangle, remember that the aggregate supply without the tax, when seen from the right perspective, is also the aggregate marginal cost curve. And this locus without the tax is also the aggregate marginal benefit curve. And what we need is the area between those two curves and the quantities with the quantities produced with the tax and without the tax. Now we can use the same tools of comparative statics that we developed before to study what is the marginal effect on the equilibrium of a marginal change in the taxes. How do we do that? We know that at equilibrium, the following relationship has to hold, which is the amount demand, and this is the demand curve without the tax, at whatever the equilibrium price happens to be. So this is P star of tau is the equilibrium price as a function of tau, plus the tau, that's the amount demanded by consumers, has to be equal to X supply times P star of tau. That's the amount that firms want to supply. Again, this is with no tax. Now, we can take derivatives on both sides with respect to T, or sorry, with respect to tau, the tax, and we get that the derivative of the demand with respect to tau, sorry, with respect to the price, the function of the price, times the derivative of what is inside here with respect to the tau, which is the derivative of P star with respect to tau plus 1, has to be equal to the derivative of the supply, Knox tau, respect to P, times the derivative of P star with respect to tau. Now, this gives us a formula for what is the marginal effect in the equilibrium price of a change in the tax, which is going to be equal to the derivative of the demand with respect to no tau dp, wherever it was, times the derivative of x of the supply, again no tau with respect to the price, minus the derivative of the demand with respect to no tau with respect to the price. Now notice that this is negative because demand decreases with prices. This is negative. This is positive, and therefore together this is negative. Now we know the sign. The question is, what is very interesting is what is the magnitude, and this formula is telling us that it's going to depend particularly a lot. It's going to be proportional to what is the sensitivity of the demand curve to respect to price. So for example, if we are in a situation, let's say start at tau equals 0, in which the demand curve, let's say something like this, okay, and let's say that the initial equilibrium is here. Now, at this particular point, the demand is not very sensitive to the price. You can tend to demand the same thing at any local price. So, for example, in this particular case, the change in the equilibrium price with respect to a marginal change in tau is going to be approximately 0. That's what the formula is telling you. Whereas, for example, if you're in a situation like this, let's say this was the supply, this was the initial equilibrium, in which now the amount demanded is very sensitive to changes in prices. In this particular case, the introduction of the tax is going to give you a large change in the equilibrium price.